Our topic is inattentional blindness, and many of you are likely to be familiar with it thanks to the famous invisible gorilla experiment by Simons and Chabris. Most of us have been fooled by this experiment, so let's talk about the gorilla in the room. First of all though, what is inattentional blindness and why do people fail to see the gorilla? Well, this is defined as a psychological phenomenon in which individuals fail to perceive a fully visible but unexpected object in their visual field when their attention is directed to another task or element. From this definition, we can rescue two very important elements from cognition that allow for unintentional blindness to happen, and these are attention and perception. The phenomenon was first studied by Arian Mack and Irvin Rock in 1998, and these scientists concluded that conscious perception relies on the availability of attention. So we're going to talk about attention and perception as two cognitive processes that are intertwined. And we're going to start with the role of attention in this phenomena. The article titled "What's Unintentional About Unintentional Blindness" explains that this phenomena occurs due to selective attention, specifically object-based attention and spatial attention. Object-based attention is selective attention to an object rather than to a point in space, and spatial attention is the ability to attend to specific regions in space. Both enhance the attended information and suppress information that doesn't align with our specific goal. This allows for the unintentional blindness phenomenon to happen. In the invisible gorilla experiment, for example, the intended task was to count the passes of one team, and most people failed to notice the gorilla since this information is not related to the initial task. Despite the gorilla being in the center of the frame, it is not perceived by most individuals. Just like the findings of Mack and Rock, conscious perception did not occur due to the lack of attention. So let's break down how selective visual attention works. It's how your brain decides what to focus on in a busy world. First, the primary visual cortex in the back of your brain kicks things off by processing basic visual information like colors, edges, and motions. From there, the brain splits the work. The where pathways track motion and location, and the what pathways figure out what that information is. Next, the parietal cortex filters the scene, helping you focus on what's important, like spotting a friend waving in a crowd. Then, attention gets fine-tuned. Regions in the prefrontal and parietal areas team up to set goals, resolve conflicts, and even guide your eye movements to stay on target. Once you're locked in, the temporal lobe digs deeper to recognize faces, objects, or words. Meanwhile, the thalamus and prefrontal cortex work to keep distraction at bay so you can stay focused. Finally, the motor cortex helps you act, whether that's shifting your gaze or reaching for something you've spotted. With all those regions and areas, that is how the brain seamlessly handles attention. So as you can imagine, unintentional blindness can have serious impacts outside the invisible gorilla experiment. Car accidents, for example, can be linked to this phenomenon. It is common that these occur because drivers fail to notice another vehicle or pedestrian despite looking right at them. So it can be said that unintentional blindness has both safety and health consequences. Even expert observers are susceptible to unintentional blindness. A study conducted by the Association of Psychological Science in 2013 showed that 83% of radiologists in a sample failed to notice a photo of a gorilla when tasked with finding nodules in a lung scan. This is directly related to unintentional blindness because the information related to the goal is enhanced, but the rest is suppressed. There's also been evidence of doctors leaving objects like catheters, gauze, and clamps inside of patients after surgery. This is a study focused on the medical field, but it can be implied that other professionals like pilots, surgeons, or police can be victims of unintentional blindness, leading to possible serious consequences. This phenomenon is something that can be experienced across age, gender, and any other defining category you may imagine. However, older populations of adults do tend to be more susceptible to this phenomenon due to their cognitive decline associated with age. Additionally, individuals under the effects of drugs and/or alcohol may also be more susceptible to unintentional blindness. It is common belief that unintentional blindness affects only a certain population due to factors like cognitive abilities and personality traits. However, Simons and Ding found that it is false. There is no existing literature that provides convincing evidence that proves these factors influence whether they are going to be affected by this phenomenon or not. Furthermore, the results for this study indicated that the occurrence of this phenomenon is more related to the demands of a task rather than the age or gender of the individuals. But that, in essence, is what unintentional blindness is, focusing so intently on one thing that we completely miss something unexpected right in front of us.